Hey there and welcome to AI Lab 99. Today we'll be building our second application, the Energy Consumption Predictor. We have a dataset containing temperature, humidity, and the consumed energy data. Our goal is to predict the energy consumption based on temperature and humidity inputs. We'll develop a machine learning model and deploy it as a web application as demonstrated here. Let's begin. Let's launch the Jupyter Notebook. Now go ahead and create the new notebook. We'll begin by importing pandas. Import pandas as PD. Next, let's load our dataset into a data frame using the read CSV function. And to quickly take a look at the first few rows, we'll use df.head. We can see that there are three columns: temperature in Celsius, humidity percentage, and the consumed power in kilowatt hour. Let's run df.describe to take a look at the stats. We see that the count is 500, which means there are 500 data points in the dataset. The minimum temperature is around 0 degrees Celsius and the maximum is around 39.7 degrees. The minimum humidity is around 10% and the maximum is around 90%. The minimum energy consumption is around 76 kilowatt hours and the maximum energy consumption is around 369 kilowatt hours. Now let's go ahead and plot the data. Importing matplotlib, I want to create a scatter plot with the temperature on x-axis and energy on y-axis, adding the title of the plot and labeling the x and y axis by using x label and y label. We can see that there is a clear positive correlation between the temperature and the energy consumption. As the temperature increases from 0 to 40 degrees, the energy consumption generally increases from 80 kilowatt hours to 350 kilowatt hours. However, the data is scattered around this general trend, indicating that the temperature alone is not sufficient to predict the energy consumption. Let's plot another scatter plot with humidity on x-axis and energy on y-axis. This plot also shows an upward trend between humidity and energy consumption, but also shows a similar data scatter indicating that humidity alone is not sufficient to predict the energy consumption. Now let's plot a 3D scatter plot with temperature, humidity, and energy consumption. I'm specifying temperature on x-axis, humidity on y-axis, and the energy consumption on z-axis. This 3D scatter plot combines both previous relationships, showing how temperature, humidity, and energy consumption interact together in three-dimensional space. To make this plot more interactive, let's run this code from a Python file instead of a Jupyter notebook. Creating a Python file, loading the dataset, and putting in the 3D scatter plot code. Running the code. We can now interact with this 3D plot and examine the relationships from various perspectives. From this angle, we see the 2D relationship between temperature and energy consumption. And from here, we see the 2D relationship between humidity and energy consumption. However, when we rotate the plot in this specific viewpoint, we discover a different 2D perspective where the data points align in such a way that a straight line could fit through them quite effectively. This alignment demonstrates that combining both temperature and humidity as input variables, we will be able to provide strong predictive power for the energy consumption. So let's split this data into feature set and the target variable to feed them into a linear regression model. There are two features, temperature and humidity, so this will be a multiple linear regression model with two features. Now let's split the dataset into train and test sets, importing train test split from Scikit-Learn. I want to split both x and y, so adding them as arguments, and then specifying the test data size to 0.2 and a random state so that I get the same split when I run this code again. This function will give four variables: xtrain, xtest, ytrain, and ytest. Let's print the shape of all these variables. We can see that there are 400 data points in the train set and 100 data points in the test set. When we specify the test set size to 0.2, we are taking 20% of 500 data points in test set and 80% in the train set. Now let's use these datasets to build our linear regression model, importing linear regression from Scikit-Learn, creating a model, and executing model.fit on X train and Y train. The model is now ready. Let's make a prediction on this model. We'll run model.predict. First input will be the temperature, and the second input will be the humidity. Let's give 20 degrees Celsius and 50% humidity. It says 221.2 kilowatt hours. So what's happening inside when we execute model.predict? There would be a model equation which is in the form of y equals w1x1 plus w2x2 plus b. Here, y is the energy, x1 is the temperature, and x2 is the humidity. Similarly, w1 is the coefficient of temperature, w2 is the coefficient of humidity, and b is the bias. When we executed model.train before, the model has come up with the values of W1, W2, and B such that when the inputs of temperature and humidity are given, they would be substituted in this formula along with the obtained weights, and the energy consumption would be predicted. So what are the values of the coefficients and the bias here? We can get them by executing model.coefficient and model.bias. We can see that the coefficients are 3.4 and 2.0. 3.4 is the coefficient of temperature and 2.0 is the coefficient of humidity. The bias is around 53. With these values, let's write our own predict function, creating a function, predict energy consumption, that will take temperature and humidity, will return 53 plus W1 times temperature, that is 3.4 times temperature, plus W2 times humidity, that is 2.0 times humidity. Let's run this function on the same inputs, 20 and 50. We see the same output as model.predict. Now, how do we interpret this model? From the line equation, we can see that if the temperature and humidity are 0, we get 53. So we can interpret the bias term of 53 kilowatt hours as the base energy consumption value. On top of that, if we look at the coefficient of the temperature term, we can say that every 1 degree rise in temperature contributes to 3.4 kilowatt hours rise in energy consumption. Similarly, when we look at the coefficient of humidity term, we can say that for every 1 degree rise in humidity, the energy consumption increases by 2 kilowatt hours. In the final step, let's quantify the performance of the model. We'll calculate the root mean squared error, which gives a mathematical insight on how well the model is performing. Importing mean squared error from Scikit-Learn. This function takes two inputs, the actual values and the predicted values. Giving in the train values, this gives us the mean squared error, and when we add a square root, we get the root mean squared error. This is the train RMSE. Let's calculate the same for test data points. Printing both the values, we can see that the RMSE on train predictions is around 9.6 and the RMSE on test predictions is around 10.5. This means that when the model predicts an energy consumption value to be around 100 kilowatt hours, the actual value of the prediction might be plus or minus 100, which is around 90 to 110 kilowatt hours. Given the range of the energy consumption values in the dataset, which is between 76 to 370 kilowatt hours, the margin of error here is pretty small. Second point is that the RMSE on test data, which is around 10.5, is something that the model has achieved on unseen data, which is very close to the RMSE on trained data. This indicates that the model is reliable on new data points too. With this, we conclude the model building part. Now let's create an interactive web app. I just created a new Python file. We'll use the Streamlit package to build the web app, importing Streamlit, adding the title that will be displayed on the home screen, adding a prompt for the user to enter the temperature and humidity to predict energy consumption, adding a number input field that takes in the temperature. Here the minimum value is minus 50 degrees Celsius and the maximum is 60 degrees. And we'll keep the step to 0.5. Adding another input field that takes in humidity. Minimum value is 0 and the maximum value is 100. As the humidity is measured in percentage, this step is 1%. Adding a button called predict Now, when the button is clicked, the predicted energy consumption value should be calculated and displayed on the screen. Let's bring in the custom prediction function that we have written earlier. Using this function to make the prediction from the number inputs, adding a success message that displays the predicted value. That's it. Let's run the file. Running the command streamlit run app.py. And here is the web page with the title, the prompt, and the input fields. Let's give a couple of inputs for temperature and humidity. We see the prediction. Let's change these values. We see more predictions and so on. With this, we have successfully built and deployed our second machine learning project from start to finish. All the code and the dataset is available in a GitHub repository linked below. Until next time, happy coding.